Hey guys, so this section is going to cover 10-4, solving radical equations. This is pretty straightforward because all you are doing is essentially getting the x variable alone. You just have to use the correct inverse operations to do that. The main thing that's going to be happening in this section is that towards the end of the problem at some point, you're going to have to isolate your radical by squaring both sides of the equation. And this first example is going to give you that basic idea. As you can see, we have radical x plus 7, and in order to get radical x all by itself, you're going to subtract 7 from both sides because we are adding 7 right there. When you subtract 7 from both sides, 16 minus 7 is going to be 9, which you can see right there. But after that, very important step, you are going to be squaring each side, like you can see right here with the starred note. Remember, anytime you have the square root of a number and you are squaring the square root of that number, the result you get back is just that number. So likewise, if you are taking the square root of x and you're squaring it, like we're doing right here, well, the result that you get back is just the variable x. But remember, we are squaring both sides, each side. So because 16 minus 7 is going to give us 9, we square both sides, and 9 squared is 81. So 81 is our final answer. You can see how to check your answer down here at the bottom by plugging the 81 back in for x. But here's a practice problem for you to do. And I would say just quickly pause the video and do that really quickly. So the first thing you would do here is just add 5 to both sides, and then the square root of x is going to equal 3. And then square both sides, and 3 squared is 9. So let's look at another problem, one that involves a little more work. As you can see, we have a radical expression on both sides this time. The previous example, we just had a radical on the left-hand side of the equation, but in this case we have a radical on both sides. So here's the first step, very important. You are squaring to begin the problem. We cannot add 11 to both sides because the 11 is underneath the radical sign. Likewise, we cannot subtract 5 yet because the 5 is underneath a radical sign. So our first move in this particular problem is that we have to square both sides of the equation in order to get the radical signs to go away. Well, when you do that, you are at this point in the problem, which is pretty standard. The next thing that you could do is subtract t from both sides. You could add 11 to both sides, divide by 4, and you get t equals 4. If you need to pause the video and read the summary that's going on right here, please do that. Otherwise, just pause the video and do this example right here at the bottom and see if you understand. So the first thing you would do down here at the bottom, you would square both sides, and you would get 7x minus 4 equals 5x plus 10. You have many options for what you could do next, but let's just say you subtract 5x from both sides. You will be left with 2x minus 4 equals 10. Add 4 to both sides, and then divide both sides by 2, and you get x equals 7. Again, you're just doing your inverse operations, and in this case we had to square both sides because both sides of the equation were underneath radical signs. So that was what we had to do first to get rid of the radical. Alright, here's probably the most challenging aspect of the lesson, talking about extraneous solutions. Listen very carefully. An extraneous solution is basically an extra solution, and it happens when you square both sides of an equation. It doesn't happen all the time. It only happens sometimes. But basically, here's the idea. Let's say your original equation just says x equals 3. 3 is the only value assigned to x. X cannot be any other number. Let's just say x equals 3. Well, in general, it is okay if you square both sides of an equation. You're doing it to both sides, and it's an operation. You can do it without violating any rules of math. X squared is going to now equal 3 squared. We are squaring both sides of the original equation. So x times x is x squared, and 3 times 3 is going to be 9. Our new equation is now going to say x squared equals 9. But here's the thing. Let's say we were just looking at x squared equals 9. Let's just say we didn't know that our original equation was x equals 3. Well, to get x alone, you would have to take the square root. And if you remember from chapter 9, when you take the square root of a number that is positive, like 9, well, you're going to get two answers. You're going to get plus or minus 3, because positive 3 times itself equals 9, and negative 3 times itself equals 9. So because you could take the square root of 9 and get plus or minus 3, well, we now have a problem. The original equation told us that x is only 3. But after square rooting 9, we just got two answers, positive and negative 3. So that means negative 3 is an extraneous solution. The original equation only had 3 assigned to x. But after we square rooted 9, technically that could be negative 3 as well. But we have to cross that off of our apparent solution list because negative 3 was not what was assigned to x at the beginning of the problem. Here's the basic idea. This would be something to write down for the sake of your notes if you are taking notes with the video. An extraneous solution is an apparent solution that does not satisfy the original equation. And that's it. If you were to substitute, if you were to plug the apparent solution back into the original equation, well, that's how you would check if the solution is extraneous. Let's go ahead and look at this example down here at the bottom, and you'll see kind of how this comes to be. Basically, in general, you're not going to know an answer is extraneous until the end of the problem when you go back and check. So either way, you're going to be solving these equations with the methods that we've been talking about. You just now have to check your answer at the end to determine if it's extraneous. And remember, this only happens when you square both sides of an equation, and it doesn't happen all the time. So let's look at this first example down here. As you can see, we are taking the square root of n plus 12. So your first move would be to square each side to get the radical sign to go away. N times n would be n squared that you can see right there. And when you take the square of something that is already being square rooted, well, you get that same thing back. So the square of n plus 12, of the square of the square root of n plus 12 is just the n plus 12. Next, very important step. Every single time you see a number that is being squared, or a variable that is being squared, I should say, that means in order to solve the equation, you're going to have to set your equation equal to 0. This is a standard rule with quadratics. Every single time you see some variable being raised to the second power in your equation, you will want to set it equal to 0 in order to solve or factor it. So as you can see, we have n plus 12, and we need to set this equal to 0. So we're going to subtract n and subtract 12 from both sides. So you're going to have a negative n and a negative 12 on the other side of the equation. And notice that it is now equal to 0. So at this point in the problem, we are now doing something that we last did in Chapter 8 and Chapter 9. We are factoring this quadratic equation. And you would want to do this by asking yourself the question, what are the factors of negative 12 that add or subtract to make negative 1? And that would be a negative 4 and a positive 3. And then again, the only way you get n squared is if you have an n and an n as the first terms of your binomials. Review Chapter 8, I believe Section 8-5 if you need more help with that. In any case, we have set this equation equal to 0. So we need to determine what values for n make these binomials equal to 0. Well, if it says n minus 4, then n equals 4. Or 4 minus 4 is 0, so n could be 4. Likewise, it says n plus 3. So that means in order to make that 0, because remember, we're doing this since negative 3 would be the answer in that case, negative 3 plus 3 is going to be 0. And then the n minus 4 binomial, well, it's going to be multiplying 0. And anything times 0 is 0. So that's why we are doing this. We're just using that zero product property. But in any case, these are our answers, n equals 4 or n equals negative 3. But we have to check to see if one of these answers are extraneous. And you do that by just plugging in your values to the original equation being right here. So as you can see, there is an n on the left-hand side, which we are going to first make 4. So now we're down here at the bottom. And then we're going to plug in 4 for the n that's underneath the radical. 4 plus 12 is 16. And the square root of 16 is 4. So 4 equals 4. And that's good. That's a true statement. That means 4 is a correct solution. But over here, when you plug in negative 3, you make n negative 3 on the left-hand side. But when you plug negative 3 in for the n that is under the radical, well, negative 3 plus 12, that's going to be 9. And the square root of 9 is positive 3. And positive 3 is not equal to negative 3. So that means that is an extraneous solution. Negative 3 does not equal positive 3. I know you might think that, okay, we're taking the square root of 9, and that could equal negative 3. But in this particular case, we're just looking at the positive square root answer to show that they're not the same. In general, when you plug your answer back in, especially on the end of course exam, it will be blatantly obvious if it is extraneous. Just remember, when you square both sides of an equation, sometimes you get extraneous solutions. Let's talk about one more aspect of this lesson, and then I'll give you the practice problems. Sometimes you get no equation, and it's very simple. You just do the same procedure to check by using your inverse operations, and then at the end you plug your answer back in, and then you'll see that it's not going to be a true statement. So in this one example, here we are, we're right here. Your first step would be to subtract 8 from both sides, and 2 minus 8 is going to give you negative 6. You would then square both sides to get the radical sign to go away. When you square the square root of 3y, you just get 3y. And when you square negative 6, you get 36, which we have right here. Then divide both sides by 3, and y is going to equal 12. But here's the thing. 12 is your only potential answer. So let's go back and check to see if it is an actual answer or if it is extraneous. Well, when you plug in 12, well, 3 times 12, that's going to be 36. And the square root of 36 is just 6. And then it says plus 8. Well, 6 plus 8 is 14. And 14 does not equal 2. Notice the original equation was set equal to 2. And when we plugged in y being 12, well, we got the left-hand side of the equation as 14, not 2. So because that's not a true statement, 12 does not satisfy the original equation. And since 12 is the only potential answer, as it says right here, that means the original equation has no solution. And that's it. Here's a brief summary of what we've been talking about with this section. Basically, you're going to have to square both sides to remove the radical. That's the main thing when you see both sides or maybe one side having a radical sign. You will have to square both sides of the equation at some point to make the radical go away. But keep in mind, sometimes extraneous solutions are going to be created when you square both sides of an equation. The only way you can figure out if a solution is extraneous is if you go back and plug your answer in to check. So plugging your answers back in, essential to this section. Alright guys, here's some practice problems that I'm going to work out. I would recommend pausing the video and doing these 5 problems and then unpausing and seeing how you did. Alright, here's a quick run through of numbers 1 through 5. The first thing in number 1 would be to subtract 10 from both sides, then square both sides. You get 3x equals 36. Divide both sides by 3, and x is going to equal 12. 12 is your potential answer. You would now want to plug it back in and see if you get the same thing on both sides. 3 times 12, look down here at the bottom. 3 times 12 is 36. And the square root of 36 is 6, and 6 plus 10 is 16. So that's a true statement. 16 equals 16. That means our apparent answer of 12 is a good answer. Number 2, you would start off by squaring both sides. But if you notice right here, there is a 2 in front of the radical r minus 1. That 2 also gets squared when you square both sides. Also notice, r minus 1 is a quantity underneath the radical sign. meaning after you square it, it is still a quantity all by itself within parentheses. It's very important that you do not write down 4r minus 1 without parentheses, because the next step in this problem, well, that would be to use the distributive property. And as you can see, after you distribute the 4, you get a minus 4 at the end of the problem. And over here, if you did not write it with parentheses, you would have a minus 1, and that would be getting you the wrong answer. In any case, once you square both sides and you distribute the 4, you now have a very standard equation that you are going to have to solve. Add 4 to both sides, subtract r from both sides. You get 9 equals 3r, and after you divide both sides by 3, r equals 3. But back up here, 3 is a potential answer. Let's go back and check to see if 3 is an actual answer. When you plug in 3 for r, you're going to have 3's in those locations. Over here on the left-hand side, 3 plus 5 is going to be 8. And on the right-hand side, 3 minus 1, that is going to be a 2 under the radical sign. Now you might think that it is not going to be the correct solution because we have a radical 8 and a radical 2, and those are different radicals. But remember, very important idea here, every single time you have a number that has a perfect square that divides it, you have to simplify that radical. Radical 8 can be radical 4 times radical 2. And because radical 4 is a perfect square, you would square root it to get 2. So now you have 2 radical 2 equals 2 radical 2. That's a true statement. And you have now just proven that 3 is a good answer for this equation. So again, every single time you have a radical that involves a perfect square, you need to split that number into its perfect square in order to simplify. Problem 3. You would start off by squaring each side. So you now have 2x minus 1 equals x squared. Here's another quadratic. Every time you have an x squared or a variable being squared in your equation, you need to set that equation equal to 0 by doing the proper inverse operations. You would want to subtract 2x and add 1 to both sides. Something to keep in mind as well, your leading term should be positive. I did not subtract x squared from both sides because that would have given me a negative x squared, which is not going to help you. You would have to then multiply the entire equation by negative 1 in order to make the x squared positive. But in general, with standard form, the value of x squared or the coefficient a in front of it, that should be a positive value. In any case, we now have a quadratic. It has been set equal to 0, so we now need to factor it into its appropriate binomials. Because we have an x squared term in the front, we know that our first terms are going to be x and x. You would then ask yourself the question, what are the factors of positive 1 that would add or subtract to make the negative 2? Well, the only way you make a positive 1 with numbers that you can add to make negative 2 are if both of those values are going to be negative 1. So you have the same binomial twice. And the only value for x that makes these binomials equal 0 is 1. But again, that's a potential answer. Let's now plug it back in and see if it works. 2 times 1, that's 2. 2 minus 1 is 1. The square root of 1 is 1, and 1 squared is also 1. So it does check out. 1 is a correct answer. Question 4, pretty quick and easy. You square both sides. You get x minus 3 equals x plus 5. Subtract x from both sides. Add 3 to both sides. You get 0 equals 8, but that's not true. So that means there's no solution in this problem. Last one, number 5. You would start off by squaring both sides. And then you would have s squared equals the square, or s plus 2, because you square the radical s plus 2, and then it just becomes a normal s plus 2. Set it equal to 0, you have a quadratic. Every time something is being squared, you will need to set your equation equal to 0 in order to get that answer. Subtract 2 from both sides. Subtract s from both sides. S squared minus s minus 2 is now going to equal 0. We had a positive s and a positive 2 on the right-hand side, and after we did the inverse operations of subtracting them, we now have a negative s and a negative 2 on the left-hand side. factor your binomials. You know you're going to have two binomials. You know the first terms are going to be s and s. The factors of -2 that can add or subtract to make -1, because that's what we have right there in front of that s in the middle. Well, those numbers are going to be -2 and +1. And you can always FOIL to check your answer if you are not sure. Remember that. FOILing will allow you to check if you have factored correctly. The only possible answers would be s equal to 2 or -1. So immediately, if you look at number 5, we know the choices B or D are not options because those weren't even apparent answers to the problem. So plug in 2 or -1 and see which one works. If you plug in 2, it's going to say s equals the square root of 2 plus 2, which is 4. Well, if s is 2, the square root of 4 is also 2. That means 2 is a good answer. So that must mean our extraneous solution has to be -1, and here's why. When you plug in -1 on both sides, notice on the right-hand side of the radical, it will now say -1 plus 2, which is really 1, and the square root of 1 is +1. Remember, we're taking the positive square roots whenever we're doing these extraneous check answers, so because -1 was all by itself on the left, and when we square rooted 1, we got +1, they are not equal to each other. So that means C is your choice for the extraneous solution. Alright guys, with that being said, here are some practice problems. I recommend pausing the video and working out as many of these as you have the time to do, but of course the ones at the bottom are the ones that really matter more just because they are more involved, more complicated. So pause the video, and when you hit resume, I'll go to the last slide. Alright guys, here are the answers. Hope you got a lot of it right. Please come in and ask questions. 10-4 has been a pretty easy section so far, but of course practice and we'll be all set. Alright guys, see you later.